Okay, how would we do this synthetically? Everybody know?
So if it's more than one figure on top, it's just like there's no asymptote.
So if it's more than one bigger, yeah, there's no, because an asymptote implies that it's something that's linear, right? So if the top were, you tell me, what do you think is going to happen? If the top polynomial is 2 degrees, is a degree 2 higher than the bottom, instead of an asymptote, what's the overall shape of the function going to look like on a large scale? Yeah, it's going to look parabolic. So we call it an envelope in math. Sometimes that's a good word to describe that. So if you were to pan way out, you'd see this parabolic envelope that describes the end behavior, and then locally there'd be some deviations from that. But we don't really mess with that. You know, with asymptotes, we're just looking for something really quick and easy to graph. It'll make more sense why we wouldn't probably mess with that when we get later on in the class when we do curve sketching. Because what we'll end up doing a lot of times is we'll create the asymptotes first. That gives us the bones of the sketch, and then then there's not many options left. We just got to plot a few points and we can see what it's going to do based on the asymptotes. Okay, what about this? There might be another way to do this synthetically. Yes, sir.
No, I was going
Oh, go ahead. What's that? Okay.
When we find the zero at the bottom to
So,
automatically?
yeah, so what you got to do, and you can't just find the zero at the bottom. You have to actually reduce the fraction to where it looks like x plus or minus some number on the bottom. And it could be fractional. So in this case, what we have to do, in order to get the bottom to look like this, it's got to look like x, in this case, x minus something, right? What do we have to do to both the top and the bottom? What you can think of it as factoring something out. What do I have to factor out from the top and the bottom to have the coefficient of x be 1? 3, yeah. Well, everybody close these down for a second. This is actually something that doesn't show up in textbooks. You won't see this anywhere else, but it's something I think this is fairly important to see. So if we factor a 3 out of the top, it's pretty easy. What's left on the top? Minus 1. On the bottom, what do we get? Okay, I heard it. X minus 2/3. Right? I'm just dividing a 3 away from each term. Okay, so then algebraically I can cancel the 3's, and this is what I'm left with. Okay, so then when we set up our synthetic bracket here, on the top, everybody agree we just get a 3, a 0, and a -1. Okay, and then outside, the 0 of the bottom is just positive 2/3. So now we just do this regularly. I just pop the 3 down. 3 times 2/3 is 2. 2 plus 0, 2. 2 times 2/3. Okay, and then -1 plus 4/3. Okay, so then that's going to give us, what's this tell us? So this has got to be, this is the remainder. So then we just inch over to the left from there. That's got to be constant coefficient of x, x squared, x cubed if they were there, right? So this just becomes 3x plus 2 plus 1/3 over x minus 2/3, right? Well, that's kind of the inconvenient way to write that, but we honestly don't really care about that part now, do we? Right? If we wanted to rewrite that, I mean, it's for future reference. What could I do? Well, I could multiply it. Why don't I just distribute a 3 through the top and the bottom, right? And then that term would just become 1 over 3x minus 2. Everybody see that instead? And so our final simplified version of that, we just have a complex fraction there. Right? Another way to approach this would just be to simplify the top, simplify the bottom, and flip and multiply. Either way, you're going to get this, right? So we end up getting the very same thing, hopefully, if I did this right, yeah, that we got there, right? Okay, make sense? So you can do synthetic division on this, but you just, the key step is you just have to get on the bottom x with a coefficient of 1 plus or minus some fractional value, okay? All right, quick reminder, there you go. Have at it.